Thank you very much for the kind introduction and also for the invitation to be in this very nice event. Francisco mentioned the title of my talk, and I'd like to mention that the funding from my research comes from CERC, which is the Swedish Science Research Center, and from the Göran Gustafsson Foundation. The Sustainable Development Goals have been introduced in previous presentations, so I will not spend too much time on them, but just to highlight that they span a very wide range of topics, from no poverty to climate change, of course, but also aspects such as social stability, equality, gender equality. And that very wide range of topics requires multidisciplinarity and very hard work in really mixing all the areas of knowledge and that extra effort to be able to communicate in the same language and efficiently collaborate and work together. So we took the framework of the SDGs, which contains 17 goals and a total of 169 targets. I will be mentioning this in a bit more detail in a second, because it's a very standard framework to really assess the progress towards sustainability. And we had this question, this research question, of whether there is published evidence for positive or negative effects of AI development in each of these SDGs, in each of these goals. This work was published last year in Nature Communications, so you can see the reference here. If I will just highlight some of the main examples, but there is a very complete list with hundreds of references there, so if you're interested, you can just dive in there. And of course, to be able to address this question, one needs to compile a very multidisciplinary team because of the wide range of areas that are involved in this set of goals. So this team, you can see it here, 10 people all around the globe, including experts in AI, in engineering, in more applied AI, but also in more, let's say, social AI, as well as experts in ethics, in law, in economy, and the Sustainable Development Goals, of course. We also had Max Tegmark from MIT, who is a visionary on AI sustainability. And we had a quite nice interaction to be able to discuss and formulate our conclusions based on the publications in the literature when it comes to this effect, AI and sustainability. So we divided all 17 SDGs into the three main pillars that have been mentioned before when it comes to the society, the environment, and the economy, because that way we can actually analyze the three areas globally and the connections, both in terms of synergies and trade-offs. And after doing that division, we had this iterative process. So we had the 17 goals. We had experts who were assigned each of the goals. In this case, these two people here were the experts who had to search the literature for research projects. Some, let's say, industrial projects, but the emphasis was mostly on research at the research level, documenting references, reliable references, with positive or negative effects on each of the targets. And this would be SDG 1 and all the targets associated to that goal. You can see here that we have for each target 4 or 5 references, documenting positive or negative effects that you can see in this column over here. And then there was an iterative process with reviewers. So in this case, we had 2 reviewers, and we perform an expert elicitation process to reach a consensus regarding the team's view on the status of AI for that particular SDG and all its targets. So this was a quite rewarding and interesting process, also quite time-consuming. We took quite some time to really be able to assess the literature, but we managed to compile these results that you can see here. So basically, we divided those 3 areas that I mentioned before. And from the 169 targets, 79% can be positively affected by AI. That's one of the conclusions. However, 35% of the targets can see their achievement compromised because of the development of AI. And of course, if you just look at the numbers like this, well, clearly AI is helping, but one should not underestimate the negative effects, because it's only enough to have a catastrophic effect in one target to really challenge and to really kill all the progress on the positive side. So one first conclusion is one should not just look at the numbers, one should look at the negatives and be very careful about them. And the second one is that one should look at the interactions among targets and the synergies that exist. What you can see here is that the environment in principle is the one with the highest positive impact from AI in a number of areas that I will mention in a minute. And perhaps the society is the one that could have the highest negative impact of AI. But the most interesting, I think, is to look in detail, to go into each of the SDGs and to try to understand a little bit how these interactions are taking place. So what I'm showing on the left is for each of the SDGs the positive effects of AI, so the percentage of targets that are positively affected by AI, and on the right, the negative effects. You can see two lines. The lighter color is the one that we're going to focus on first. I will get back to the darker one in a second. And what you can see is that clearly, as I mentioned before, well, the green area is larger than that is yellowish in this screen area, which means that the effect is in principle more positive than negative. But in some of the targets, I mean, if you look at SDG 1 on no poverty, there is quite some negative potential also from AI. So this can be analyzed in detail, of course, and in the article you have all the examples. But we don't want to compare pears and apples. I mean, there are different types of evidence, different types of references. So what we did was to classify all the references into 4 categories, ranging from A, like in a school, to D. That's not so good. And the types of evidence that we found were ranging from the A class, which would be very robust evidence, easy to generalize, easy to really apply in real full-scale projects, or at least scalable. And the class D are the most, let's say, speculative or less based on less sound science, based on the iterative process with the experts that I mentioned before. So after doing this, we assign weighting factors from 1 to 0.25 to, well, kind of take into account that strength of the evidence. And when we do that, we look again at this figure, and now we look at the darker colors, so the inside lines. Of course, because the weighting factors are from 0.25 to 1, the darker color is smaller or equal than the lighter one, so there is a reduction in many of the SDGs. And now is when things become interesting if we compare the light and the dark color. You can see that in the environment and on the society, the positive effects are quite robust, because there is almost no decrease of these lines going from the light to the dark color. In the environment and the society, the negative effects are actually more speculative, let's say. However, in the economy, we see the opposite. We see that the reduction in the economy is larger than the reduction in the negative part. What does this mean? There is a big gap in the research community regarding the positive effects of AI on the economy. There is quite some evidence, for the possibility of losing jobs and things like that. However, there is potential for positive effects, and they are not sufficiently documented, at least based on our assessment of the current state of the literature. So this is an important conclusion. This is really an area that affects everybody, and one should focus on it. And as I mentioned before, the environment has a very big potential, and of course the climate emergency that we're currently living, and it has been discussed in the 2 previous talks, we can really see quite some positive effect there. I will look at some examples. Again, I could be speaking for hours with all the targets, but I'm just going to highlight some examples. For example, in the context of SDG 1, there is quite some positive potential of AI, because, essentially AI is enabling new technology and new techniques that were not possible before. And SDG 1 on no poverty can be, tackled more efficiently using satellite data that is analyzed with convolutional neural networks in such a way that we can identify poverty regions more efficiently and more automatically. So that's one positive side of AI development. However, there are also negative sides or unintended negative consequences. For example, when it comes to inequality, SDG 10. If the future is going to depend on AI and having access to AI and the proper training, and not all the countries are going to have the same access, then we're going to increase the existing inequalities, which is a quite, let's say, obvious conclusion, but there is quite some evidence, published evidence, documenting this duality, this double-edged sword that we have with AI. There are more things to keep in mind. Talking about the environment, in the context of SDGs 7 and 13, there is, as you can see, that the targets, there are not so many targets with negative effect of AI. However, one example that I think is very important is the electricity consumption, right, associated with development of AI models and large-scale simulations in general. Right now, the electricity consumption of ICT is around 1% of the total electricity consumption worldwide. It's expected that in 10 years it could be 20% of the total consumption, which is huge, right? We don't want that. And in this sense, I think in addition to many algorithms and techniques to optimize the consumption, we should be more responsible when developing AI models. What happens? You see companies, without mentioning any names, but being very proud of using very large databases and very large AI models, and that's extremely expensive computationally, and therefore in terms of electricity, to run and to train. And what one should do is to be more aware of the data that you have, what you know about the data, and you should not just run your model and put a bunch of images there. You should embed in your AI models or whatever models you're using, whatever you know about the data, and not allow your networks to learn things that you already know, because that's a waste in terms of time and in terms of energy consumption. So I would say involve more experts in the AI technology or whatever technology you're using when you're developing the AI models. Okay. More examples. I mean, the current social and political polarization that we are living in Corona times and before, and that's of course exacerbated by social media and the AI algorithms that show you what you want or maybe you shouldn't see, but basically reinforces those biases that you already have. And I really think that there is quite some potential now with AI in the context of SDG 16 on strong institutions, with the possibility of developing regulations, which are important, but more important than the regulation, it should be the insight that you're involving experts, people who know about the technology, in the regulation process of this technology. And this is very timely because of the European Union AI Regulation Act and the UNESCO Regulation Act as well, which, I mean, they are, of course, having quite some positive sides and some negative sides that should be iterated with more experts, perhaps. So this is important, and this is one of the areas where I think one should have more discussion with experts. And another example, this is more, well, Corona related, and this is another work that we published last year in Results in Engineering, and it has to do with digital contact tracing. This is not necessarily AI, it's more data-driven methods. These apps that were for a while trendy last year and then nobody talked about them anymore. There were quite some challenges regarding the ethical implications of them. I mean, and there was quite some misinformation, let's say, in the media as well regarding these apps. My opinion, I mean, of course, this has important implications on SDG 3, on health, and 10, on inequalities, and regarding what data is being gathered and what is not. And I think that this would have been a great tool to help fight COVID. But one very important conclusion is that the data gathering should be decentralized. There is this nice protocol, the DP3T protocol, developed in Switzerland by a Spanish engineer, actually, which is really fantastic for this type of apps. And well, we have a number of criteria when it comes to the impact on the citizens, the governance, and so on, to be able to have these apps in a sustainable and ethics compliant way. All these interactions can be summarized in this figure, when the thickness of the arrows indicate the speed of change. So this clearly shows that technology is changing faster than regulation bodies can keep up with, and also the individuals which lag behind technology, but everything ends up in the governments, which should be more proactive when it comes to the regulation. And we should, of course, be very careful with environment and our very important interaction with it. And then in my last minutes, I just want to talk about one example that connects with my research. This is in the context of SDG 11 on sustainable cities. Every year, 800,000 people die in Europe because of exposure to air pollution. So this is clearly a problem. And this is one of the areas where AI can actually help to tackle this important challenge. So my main research is on fluid mechanics and use of high performance computing and AI to simulate and understand these complicated flows. I'm simulating here just one building, and what I want to do to tackle SDG 11, I mean, you can see the level of detail up to the smallest vortices, which are very, very finely resolved, is to go from sparse measurements, and these black sensors over here, to reconstruct the three-dimensional flow including not only the flow velocity, but also the thermal fields, the scalars that are representing the pollution levels, so we can have very accurate maps and also where to place these sensors to have the most information, essentially. And then, without going into too many details, because, well, we have some information in this paper, but I'm also very happy to discuss a bit more what we do. You can see here 3 different examples where we have 3 different regimes of these 2 buildings. And again, this is the highest level of detail that you can have in flow simulations. This is very accurate. And there are different ways to perform these predictions, basically going from these sensors, the individual sensors on the street, in this case, to the 3-dimensional field of temperature, of velocity, and of pollutants. Essentially, we use convolutional neural networks and GANs, generative adversarial networks, which are very good for super resolution applications. And this is a very dynamic and exciting area because we are, in a way, having problems that are so tricky that they require AI developments every day, essentially. So this is actually exciting, and it's actually quite interesting. Well, also because of the implications on SDG 11, and that hopefully we can do something good in that area as well. And that's all from my side. I'll leave you the conclusions here, the summary that we had here. I would like to thank you very much for your attention. If you want to contact me, there is also some contact information as well. And yeah, thank you very much.